A few people have asked me for a little bit more information about this installation. These are 12 85-watt panels that I installed in 2007-2008. These are BP585 panels that were made in 2002, and I purchased these panels used. And as you can see, I custom made the racking system here out of 2-inch aluminum angle. So this is 13 years ago, and there wasn't a whole lot of options. And I did have this inspected by the local utilities and the local city inspector. These panels are all running in series, and since there's 12 panels at 85 watts, it's just under 1,000 watts. This tree is starting to block me a little bit during the early morning, and 13 years ago that tree was a lot smaller. Anyways, this system has been the price that I paid for all the components was paid for long ago. I'll take you inside and show you the electronics. The previous quick video I did showed the same electronics, but I cleaned up the wiring just a touch. I'll just mention a few more things. So, as I said, this system would be rated at 1,000 watts, and this is early May, and the sun is not quite optimum angle right now. I will see upwards to 800 watts pushed out onto the system, and I think there's about a 50-watt loss in the inverter when I do some rough calculations. The warranty on these panels, well, I guess I shouldn't say it. Well, the warranty says I think they're supposed to be at their warranty period are supposed to be good to 80 watts. Some people are worried about the longevity of solar panels, and as you can see here, these are nearly 20-year-old panels, and I would wager that I'm getting 80–90% capacity off of a 20-year-old panel. Here's the electronics for this system. I used to have it just mounted to the back side of that chipboard, and I want to install some more electronics over here, so a little while ago I put up this nice piece of plywood. This is a Fronius inverter, and it has been pretty good. I have had a failure with this inverter, and it was replaced under warranty. So up here we have the string coming in, and this usually is somewhere around 200 volts DC. That's my main turnoff. I have a 14 gauge stranded wire coming over here to the inverter. This green wire is a ground that goes over to my breaker panel, and then I think this is like a 10 gauge 3-conductor wire with ground that feeds over to the breaker panel. So to get this thing to pass inspection, I had to install this DC disconnect, or a DC disconnect, even though there was a DC disconnect over here. And there's also an AC disconnect, and then there are a dual pole breaker over here that are backfed. I'll try to hold this so you can read the settings here on this display. And this is how much power I'm putting onto the grid right now. Oh, without the backlight, it's a little easier read. So right now about 750 watts are going onto the grid. Three amps onto the grid. Okay, so this is the PV voltage. As we can see, about 190 volts. 4.3 amps. And if we do a little bit of math, we can see that the inverter here maybe, if I remember correctly, is about 50 watts of losses. So let's come back to here, go a little farther. So 750 watts onto the grid, so I'm getting about 800 watts right now off of the panels. I have seen this upwards to 850 watts, maybe a little higher, but that is pretty good. These panels are rocking right along almost after 20 years of use. Okay, so I just did some quick math. We're 4.4 amps right now, 192 volts. So this is about 850 watts. You know, as it's moving around, there's a little bit of overcast in the sky. And right there, so if I'm generating 850 watts and I'm putting 800 watts on the grid, I'm losing about 50 watts of 50 watts in this conversion process. I don't have it hooked up right now, but this is kind of a little DIY project I did. This is 3 power supplies that are okay. These are standard 120 to 240 volt universal input to 12 volt output supplies that are rated at 350 watts each. My idea was I wanted to be able to, for emergency purposes, take the string voltage, which is 225 volts, connect it to this, and then I would get 12 volts on the output. And that does actually work. And since I've got 3 of these in parallel, these power supplies are all rated to work in parallel, I can get roughly 1,000 watts at 12 volts. I've never really tried that full power, but it could do it. These lugs down here aren't going to be rated for that much power, but I have drawn several hundred watts just to see if I could do it for emergency purposes. Right now it's disconnected, and I want to put in a inverter here that I can switch between this inverter and this inverter, which for emergency purposes. And that inverter will be a high voltage input to AC output inverter. So that's it. If you have any questions, let me know. 12 to 13 years of operation on this Fronius IG inverter. It has been replaced, but everything else is all pretty much original, and the panels are doing awesome. Thanks.